Hello. Today we will be solving problems on determining empirical and molecular formulas. So, according to the conditions of my problem, two substances composed of carbon and hydrogen are presented. For each of these substances, the so-called mass fractions of elements or the masses of these elements are indicated, expressed as percentages. If we express the composition of the entire substance as 100%, it turns out that the share of carbon, for example, in the first substance accounts for 85.7%, and the share of hydrogen is 14.3. This can be expressed either with the following formula, omega formula, or described in words as mass fraction. So we are given two substances for which we need to establish the so-called empirical formula, but then let's assume what such a substance might be like in the form of a molecular formula. So how are we going to work? Look, we are given elements. In this case, we are solving the first problem, carbon and hydrogen. So for each of these elements, we have specified percentages, 85.7%, and for the second, 14.3%, which is hydrogen. What do we do next? The thing is, we cannot work in percentages, so a conversion to grams is required. For this we say, let our substance weigh 100%, which equals 100 grams. And then the share of carbon will be 85.7 grams, and the share of hydrogen will be 14.3 grams. I hope this transition is clear to everyone. The fact is that the next step will allow us to find the number of moles of each of these elements. To do this, we will divide 85 by 7, recalling the formula, mass divided by molar. We divide for carbon by its mass, rounded to 12. And this result will be 7.14. For hydrogen, this value will be approximately 14.3 divided by 1. And the result will naturally be 14.3. Now let's find the ratio by moles. It will be 7, 14 to 14 and 3. To find the smallest ratio, the so-called empirical formula, we will have to divide both of these values by the smallest one, which is 7/14, and then it turns out that for carbon it will be 1, whereas for hydrogen it will be 2, and then the simplest formula we get is like this, CH2O. This is the simplest formula, but what would be, for example, the formula of a substance if, for instance, we were asked to find the molecular formula? Then I would have to inform you of one more detail. Let's say our unknown substance has a molecular formula, and this substance, it turns out, consists of an unknown amount of carbon and hydrogen, let's say. It equals, it turns out, 56. Break time. How many, for example, simple groups would be included in a given substance? Then we would find the proportionality coefficient and would say that 56. We need to divide by the mass of the simplest group, which weighs 12 plus 2, 14. And thus, in this case, there are 4 such formulas. And then the molecular formula of this substance would be as follows, C4H8. But then it would no longer be an empirical formula, but a molecular formula. Such a substance exists. It could be an organic compound, for example, cyclobutane or butane. So we have solved the first problem, and now let's proceed with a similar calculation for the second option. Let's follow the same approach. In this case, we have 92.3% carbon and 7.7% hydrogen. We proceed in the same way, converting percentages into grams, which will be 92.3 grams and 7.7 grams. Now we find the amount of substance by dividing 92.3 by 12. This gives us the number 7 rounded 7.7. And for hydrogen, it will be 7.7 divided by 1, which will also be 7.7. Then we have a ratio of 7.7 to 7.7, or 1 to 1, which means the simplest formula is CH. Well, this is the simplest formula, and let's give, for example, an example of a substance that would have such a simple formula. But if we translate it into molecular terms, then, as in the previous task, I must inform you, for example, about an unknown substance. Has the simplest formula CH, and its mass is 78. For example, the substance benzene has such a formula. And then we will calculate, let's say, the proportionality coefficient. That is, how many elementary groups there will be. For this 78, we divide by the mass of this simplest group, 12 plus 1, that is by 13. And then it turns out that we have 6 such formulas, which means the resulting molecular formula is C6C6. Such a substance exists, and it is called benzene. Thus today, we have managed to work with the derivation of empirical and consequently molecular formulas, but by solving such simple problems. In this case, careful mathematical calculations are required to ensure you don't make a mistake here, as the ratio must be correct. And I would also add that when you calculate the simplest ratio between forces, these values must be integers. If you happen to get a value that is, say, fractional and multiple, for example, 1 to 2.5, or for instance, 1 to 1.5, such values are usually not rounded up or down, but increased by 2, so that the values are integers, meaning there cannot be fractional mole ratios. Therefore, they are converted to integer values. Please keep this in mind when solving similar problems. Goodbye.